Above all, the universe continues to fascinate us with its overwhelming diversity. It's no wonder, really, thousands upon thousands of sparkling structures fill the night sky, constantly reminding us how small and fleeting our place in the cosmos truly is. Yet, alongside this dazzling abundance of celestial bodies, there are regions of the universe that seem to embody the complete opposite. These areas are not filled with galaxies, stars, or radiant nebulae. Instead, they are defined by oppressive emptiness, impenetrable darkness, and an eerie silence that stretches across unimaginable distances. Among these mysterious regions, the Boötes Void stands out as one of the most baffling anomalies known to science, a cosmic void so vast and desolate that it not only keeps astronomers on their toes but also frequently draws the attention of theorists and speculative thinkers, including those intrigued by the idea of highly advanced alien civilizations. But what does the Boötes Void truly represent? Is it really an example of the proverbial nothing, or could it help us answer some of the biggest questions in astronomy? To fully grasp the importance and the mystery of this colossal structure, we first need to understand what a cosmic void actually is. In order to explore that, we have to look at the large-scale structure of the universe. One of the key features of this structure is the existence of so-called filaments, thread-like formations composed of both visible and dark matter that form the backbone of the universe's cosmic web. These filaments connect galaxy clusters and superclusters, creating vast bridges of matter across space. Imagine the universe as an immense three-dimensional web or honeycomb, with galaxies clumped together along the filaments and the vast empty regions in between known as voids. These voids are not entirely empty, but they are extraordinarily low in galaxy density compared to the filaments. What makes voids especially fascinating is that they take up a significant portion of the universe's volume. Despite their emptiness, they're not a mere cosmic side note. The Boötes Void, in particular, measures around 326 million light-years in diameter. To put that into perspective, a single light-year is about 9.46 trillion kilometers. If a galaxy moved through space at 600 kilometers per second, it would still take over 160 billion years to cross a void of average size. Considering the universe itself is only 13.8 billion years old, it becomes clear that these voids didn't form because galaxies moved away from each other. Rather, the more likely explanation is that voids and filaments emerged roughly where they are today, shaped by processes dating back to the early universe. But what could have caused this cosmic arrangement in the first place? Scientists point to dark matter, an elusive, invisible form of matter that does not emit, absorb, or reflect light, yet exerts a gravitational pull on visible matter. In the young universe, regular matter was too evenly distributed to form massive gravitational structures on its own. It's believed that the presence of dark matter played a pivotal role in shaping the cosmic web we observe today. This interplay between visible and dark matter likely led to the formation of galaxy clusters, filaments, and the vast voids that lie between them. Turning back to the Boötes Void, sometimes referred to as the Great Void, we discover that the term void might be slightly misleading. While it's not completely empty, its galaxy density is strikingly low. Located in the constellation of Boötes, hence its name, the void was discovered in 1981 during a survey mapping the redshift distribution of galaxies. Within this enormous spherical region, researchers found only about 60 gravitationally bound star clusters. This number may sound substantial, but not when we consider the void's colossal dimensions. Spanning approximately 300 million light-years in diameter, the Boötes Void encompasses nearly 0.27% of the observable universe's diameter. With a volume nearing 236,000 cubic megaparsecs, it is one of the largest known voids in existence. There's enough space in the Boötes Void to house more than 2,000 galaxies, yet only 60 have been identified. This means the region has a galaxy density that is 95% lower than expected. To truly grasp how empty this space is, imagine if our Milky Way were situated at the center of the Boötes Void. It's likely that astronomers would not have detected any other galaxies in the universe until the 1960s. On average, galaxies in this void are separated by 5.5 million light-years. With our current propulsion technologies, it would take about 13 trillion years to even reach the void, 700 million light-years away, and then another 6 trillion years to traverse its vast expanse. That's a timescale far beyond anything imaginable within human or even planetary lifetimes. Interestingly, the Boötes Void isn't even the largest void discovered. That title goes to the KBC Void, also known as the local hole, which stretches an incomprehensible 2 billion light-years across. Other vast cosmic cavities include the Eridanus supervoid and the Sloan Great Wall Void, each over 1 billion light-years in size. Despite their intimidating emptiness, voids like these are crucial for astronomers. They provide unique insights into the large-scale structure of the universe and the physical laws governing it. Studying voids helps researchers understand the distribution of dark matter and the dynamics of cosmic expansion. From a scientific perspective, these voids act as natural laboratories, helping us test theories of gravity, galaxy formation, and cosmic inflation. When mapped in detail, the universe resembles an intricate spider web. Most galaxies lie on the filaments, the cosmic threads, while voids occupy the vast spaces in between. In fact, voids make up about 80% of the observable universe by volume. Galaxy clusters are concentrated where filaments intersect, forming superstructures like the Virgo supercluster, to which our Milky Way belongs. The Virgo supercluster itself is part of an even larger structure, the Laniakea supercluster. But while science can explain the structure and even the probable origin of voids, one fundamental question remains: why do voids exist at all? To approach this question, we have to rewind time to the Big Bang, around 13.8 billion years ago. At that moment, space, time, and matter were born from an original singularity. Initially, the universe was extremely small, hot, and dense. However, due to quantum fluctuations, some regions were slightly denser than others. These denser regions began to attract more matter through gravitational pull, slowly becoming the seeds of galaxies and clusters. Simultaneously, the less dense areas were deprived of matter, leading them to become the voids we observe today. This process, repeated over billions of years, led to the formation of the cosmic web. To visualize it, think of voids as bubbles in a foam. As time passed, these bubbles expanded, pushing galaxies outward to form the web's dense filaments. Joseph Clampett of the University of Pennsylvania likened this distribution to a cityscape. Voids are extended flat valleys in the distribution of dark matter, while galaxies lie at the center of narrow, towering peaks. A typical galaxy has the same height and footprint as the Empire State Building, while a medium-sized void would be a 3-foot-deep hole 3 times the size of Manhattan. As stunning as all this is, not everyone is satisfied with the mainstream explanation. In fact, the Boötes Void has become fertile ground for alternative and sometimes bizarre theories. One such theory suggests the void might actually be a colossal black hole. However, this idea doesn't hold up under scrutiny. Take TON 618, one of the largest known black holes, which weighs 66 billion solar masses. Even so, its event horizon spans only about 0.2 light-years. The Boötes Void, at 300 million light-years wide, would require a black hole of such absurd mass that it completely breaks the known laws of physics. As intriguing as it sounds, this theory doesn't align with any credible observations. Then comes a more exotic idea, one that borders on science fiction. Some theorists speculate that the Boötes Void is actually not a void at all, but a result of advanced alien engineering. Specifically, they point to the concept of Dyson spheres, hypothetical megastructures that encapsulate stars to harness their energy. Proposed by physicist Freeman Dyson, such structures would obscure the stars they surround, making them effectively invisible to our telescopes. If a civilization advanced enough to build Dyson spheres on a galactic scale exists, the Boötes Void could be their backyard, an entire region of stars hidden behind artificial shells. Of course, the plausibility of this theory depends on one's perspective. Is it more likely that an alien species constructed billions of Dyson spheres to hide every star in a 300 million light-year region, or that this area of space is simply less populated due to the natural processes of cosmic evolution? Subscribe to Space Lab, your portal to the wonders of the universe.